So what's a polyatomic ion? Well, a polyatomic ion is a group of atoms that has a charge. Here's what I mean. You probably already know that individual atoms can have a charge. They can form ions. So we can get things like Na+, Mg2+, and O2-. Polyatomic ions are what happens when more than one atom comes together and they form a big group of atoms, and then that group of atoms itself has a charge. So polyatomic ions are things like NO3, 1-, where we have 1 nitrogen and 3 oxygens all connected together to form a group, and that whole group has a charge of 1-. Poly means many. So here, polyatomic ions, we're talking about ions that are made up of many atoms, more than one atom. Let me show you a few examples of how this actually works. So here are two of my favorite polyatomic ions, ammonium and carbonate. Ammonium here is made up of 1 nitrogen connected to 4 hydrogens, and carbonate is 1 carbon connected to 3 oxygen atoms. Now, the atoms that are in each of these polyatomic ions, they have protons and electrons in them. So what we can do for both ammonium and carbonate is we can count up the number of protons that are in each of these atoms. If I do this for ammonium, I get 11 protons. And then if I count up the total number of electrons that are in this whole group, I get 10. So these two numbers don't balance out. I have more protons than electrons, which means that I have more positive charge. I have a net charge of 1+ because I have 1 more proton. So my net charge here is 1+, and I can write the formula for this polyatomic ion as NH4, because I have a nitrogen and 4 hydrogens, with a +1. I usually will also take the structure of this ammonium and put the whole thing in brackets and put a plus outside to indicate that this whole group of atoms together has a positive charge. I can also call this thing a cation, a polyatomic cation, because a cation is what we call ions that have a positive charge. Now, carbonate, we can do the same thing with it. We can count up the total number of protons that are in the atoms that make it up, and we can also count up the total number of electrons that are in this whole group. We get 30 protons total and 32 electrons total. So we have more electrons than protons, which means we have more negative charge. It's going to have a net negative charge, and since there are 2 more electrons, it's going to have a net charge of -2. I can write the formula for this polyatomic ion as CO3, 2-, 1 carbon, 3 oxygens, total net charge of 2-. And then I write my structure in brackets and put a 2- here to show that this whole thing has a net charge of 2-. We call this guy a cation because it has a positive charge, so we can call carbonate a polyatomic anion for negative ion. As I said before, there are a whole bunch of polyatomic ions. I have a small number of them on this list right here. A lot of times people ask me, they say, okay, if I knew that, say, nitrate was NO3, but I didn't know the charge, would it be possible for me to figure out the charge just on my own? And unfortunately, no. It's very difficult to figure out how many electrons a polyatomic ion has, and so you need that to figure out the charge. Polyatomic ions are really important for when you're writing chemical formulas of compounds.
What we're looking at is a table of 27 common polyatomic ions that you might see in a first-year college-level chemistry course or a high school chemistry course for that matter. So if you take a look at some of these common polyatomic ions, we can see that ammonium is NH4+. We can take a look down here and see that ClO2- is chlorite. We can also see that dichromate, for example, is Cr2O7 and that sulfate is going to be SO4 So all these polyatomic ions, how are you going to memorize them? And believe me, if you have these memorized, then writing chemical formulas, specifically ternary compounds or compounds that contain polyatomic ions, is going to be easy for you. So how can you memorize all these different polyatomic ions? Well, I'm going to show you a couple different ways that you can memorize these, and hopefully you'll start doing better on naming and writing chemical formulas that contain these different polyatomic ions. Okay, so it says right here that when naming polyatomic ions, remember, one key rule is that 8 is going to be bigger than 8. So what does that mean, that 8 is bigger than 8? Well, it says right here that this means that a polyatomic ion that ends in 8 will always have 1 more oxygen than its counterpart that ends in 8. Okay? And furthermore, it says a polyatomic ion with the prefix per will always have 1 more oxygen than its counterpart with an 8 suffix. And last but not least, a polyatomic ion with the prefix hypo will have 1 less oxygen than its counterpart with an 8 suffix. So what the heck does all of this mean? Well, let's take a look at an example here. Let's take a look at chlorate. If we take a look at chlorate, its chemical formula is ClO3 with a minus charge. Okay, so if we memorize what chlorate is, just ClO3 minus, then when we're asked to determine what the chemical formula is for chlorite, that should be a piece of cake, as long as we know that 8 is bigger than 8. And so what this means is that the polyatomic ion that has an 8 ending is going to have 1 more oxygen compared to the polyatomic ion with the 8 ending. For example, if we take a look at chlorate compared to chlorite, the only difference between these two polyatomic ions is that chlorate has 1 extra oxygen compared to chlorite. For example, if we take a look down here at bromate, BrO3- and bromite, BrO2-. If we take a look at iodate, IO3- versus iodite, IO2-. If we take a look at sulfate, SO4 versus sulfite, SO3 and if we take a look at nitrate right here, NO3- versus nitrite, NO2-, you will notice in every one of these scenarios right here that the polyatomic ion that ends in 8 is going to have 1 extra oxygen compared to the polyatomic ion that ends in 8. Okay, so remember that 8 is bigger than 8. Furthermore, if we take a look at the prefix per, what this means essentially is hyper. Okay, so if you're hyperactive, you are overactive. Okay, so if we drop the HY and just leave the per, what this really means is that we have 1 more oxygen compared to the polyatomic ion that ends in 8, right? If we take a look at perchlorate compared to chlorate, this little per or hyper means that the chlorate is going to have one extra oxygen on it. Okay, so per chlorate versus chlorate, you can take a look. For example, if we take a look at per bromate, it's BrO4 minus, whereas bromate is just BrO3 minus. If it has per on it as a prefix, it's going to have one extra oxygen compared to its counterpart that ends in ate. For example, per iodate means it has one more oxygen compared to the its counterpart that has the ate suffix on it. For example, per sulfate right here has 5 oxygens, whereas sulfate is just going to have 4 oxygens. And there is no per nitrate for reasons that we'll talk about in a later video. If you take a look at hypo, the prefix hypo means under. It means under. For example, a hypodermic needle goes underneath your skin, right? And so if we take a look at prefixes hypo, or polyatomic ions that have the prefix hypo attached to them, what this means is this little polyatomic ion right here is going to have one less oxygen than chlorite. So if we know that chlorite only has 2 oxygens, then hypochlorite is only going to have 1. If we know that bromite only has 2 oxygens, then we know that hypobromite is going to have 1 less oxygen. And if we know that iodite, for example, has 2 oxygens, then hypoiodite is just going to have 1 oxygen. Okay, so understand this concept. So really all you have to do is memorize those polyatomic ions that end in ate, and you should be able to use these rules that ate is bigger than ite, and you should be able to use the rule of the prefix per and the prefix hypo to figure out the rest of those little polyatomic ions. And furthermore, keep in mind that any ion that ends in "ide" is just going to be a single monatomic ion. It is not going to be a polyatomic ion. For example, chloride, bromide, iodide, sulfide, and nitride. These guys here are just monatomic. They're not polyatomic ions. Typically, polyatomic ions are going to end in ate, have endings like that. And if it ends in "ide," it's going to be a single monatomic ion. All right, so I hope some of these rules, ate is bigger than ite, make sense now. I hope you understand the concept that per is a prefix that means it's going to have 1 extra oxygen compared to the polyatomic ion counterpart that ends in ate. And I hope you understand that hypo means under. Okay, so if you have a polyatomic ion that starts with hypo, it's going to have 1 less oxygen than its polyatomic ion counterpart that ends in ite. All right, so this should help you out tremendously when you're memorizing these polyatomic ions. And so now that you have them memorized, you should be able to write the chemical formulas and for ternary compounds or compounds that contain polyatomic ions.